Why do drill bits break unexpectedly from shear failure? Imagine you're drilling into rock, and suddenly your drill bit snaps in half. It's frustrating and costly, but what causes this sudden failure? Today, we're uncovering why drill bits break unexpectedly from shear failure. Shear failure happens when the forces acting on the drill bit become too much for the material to handle. Think of it like a piece of paper tearing when you pull it apart too hard. In drill bits, this tearing occurs along a plane inside the material, causing a sudden fracture. During drilling, the bits face twisting forces called torsion, bending stresses, and impacts from hitting hard rock. When these forces combine and exceed what the drill bit material can withstand, shear failure can happen quickly. The main reason drill bits break from shear failure is because of the stresses inside the bit. Tungsten carbide, a common material used in drill bits, is very hard but also brittle. This means it resists where but can crack or break suddenly if the stress is too high. Tiny cracks or flaws inside the material can act like weak spots, making it easier for the shear forces to cause a fracture. When drilling through tough rock, the forces can spike unexpectedly. For example, if the drill bit gets stuck or hits a very hard layer, the torque or twisting force increases sharply. This sudden load can push the internal stresses past the shear strength of the material, leading to a break. The shape and design of the drill bit also matter. If the cutter placement or geometry causes uneven stress distribution, some parts will experience higher shear forces, increasing the risk of failure. Wear and fatigue are additional factors. Over time, abrasive particles in the rock wear down the drill bit, reducing its cross-section and making it weaker. Repeated cycles of stress can create tiny cracks that grow larger with each use. Eventually, these cracks reach a point where the shear stress causes the bit to snap. Rock properties play a big role too. Hard, brittle, or layered formations cause uneven loading on the drill bit. These conditions create stress concentrations, which are spots where forces are focused. These concentrated forces make shear failure more likely because the internal stresses become too high in specific areas. Operational choices also influence failure. Using the wrong drilling speed, applying too much weight on the bit, or not maintaining proper lubrication can all increase shear stresses. If the drill bit is not suited for the specific rock type, it's more prone to sudden shear failure. Understanding these failure mechanisms helps in designing better drill bits and improving drilling practices. Using materials that balance hardness and toughness can reduce brittleness. Adjusting drilling parameters to avoid sudden load spikes and monitoring the condition of the bit can prevent unexpected breaks. In essence, drill bits break unexpectedly from shear failure because the complex forces during drilling surpass the material's shear strength. This is often worsened by material flaws, rock conditions, wear, and operational errors. Recognizing these factors allows engineers to develop stronger bits and adopt better drilling techniques, making the process safer and more efficient.